The content in this video will be showed. DIY a maximum 500 watt inverter with modified sine wave. This is an inverter's bare board with a 50 Hz square wave, the low output voltage of nearly 11 volt, and maximum 500 watt capacity. This is the negative, and that positive's DC 12 volt input connectors. There are two connectors here for the output of AC 50 Hz, about 11 volt square wave. The white socket on the left is for the cooling fan, which will be placed near heat sinks of 2 on the board. The pair of wires are for in switch, with its bracket here. This switch will turn the inverter on and off. A pair of thin gray wires on the right are for the feedback, which will be connected to the output of 240 volt. This is a DIY transformer made from recycled microwave oven transformers. How to make that one, which showed from this video on my channel. This is the one with input of 8.7 volt, output of 240 volt. A DIY made inductor, which used 3 wires in parallel, total 13 turns. It can stand for maximum current of 50 amperes. That is a capacitor with its rates of 1 μF and 250 volt. It will be connected to the low voltage side of the transformer, as showed from the diagram. This is DC 40 amperes fuse with its brackets. The fuse dismantled from a car recycled. That is a DIY indicator for the output AC, and a mini voltage meter for the input DC, combined fixed on the board. All things here, plus a pair of batteries positive and negative connectors, will be secured on the board. Here we go, this is the circuit's diagram. Red and black are the red alligator and black alligator. A 40 amperes fuse is here. A DC mini voltage meter located there. The inverter bare board is here. Its cooling fan secured near to the heat sinks on the wood board. An inverter's on and off switch is here. A DIY inductor secured on the wood board. A 1 μF capacitor is there. The DIY transformer secured on the board. Its indicator for the AC output, located here. The output of AC 240 volt socket is secured here. All components are connected, as indicated from the diagram. Incidentally, the output frequency can be adjusted from here. Also, there is an adjuster for the output voltage. They've been all done from the factory. The cooling fan's wires from its socket then go along here. The switch's wires from its socket then go along this way to the switch. The feedback wires from their connectors then go here. There is also the one on the other side, both wires to the output socket pins. These points joined on both sides will be connected the meters for testing later on, etc. The one of the output connectors from the inverter's board connected to the one of the DIY inductor's end, and inductor's other end connected to the one of transformer's input terminals. The other output connector from the inverter's board connected to the other transformer's input terminal. A 1 μF capacitor connected to between the transformer's input terminals. The transformer's secondary terminals connected to a 240 volt socket pins, which will be connected to the load. A multimeter's ampere position selected for measuring the inverter's current draw without any load. Connected battery, the mini voltage meter indicate battery's voltage is 12.1 volt. Turn the switch on, now the inverter is working, AC indicator ID on, its no load current is about 3.2 amperes. Turn the switch off now. The multimeter is in AC position. The black power cord plugged into second socket from the top on the multi-socket set. A 70 watt bulb plugged into fourth socket. and electric drill plugged into third socket. Connecting the battery. Then turning the switch on. The bulb and drill are all working. The multimeter has indicated for the output. AC 243 volts. The meter has been changed to an oscilloscope now. It is indicating 50 Hz. That is the output waveform. It is modified sine wave, which can be used by the most appliances with a few hundred watt capacity, as shown in the video. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.